All right, graphing systems of equations. We have to graph each line. My suggestion is you start with the first and you plot points, or you use the cover-up method. Ends up being the same process. If we use the cover-up method, we cover up x and solve for y, or x goes to 0, y has to be 9 halves. Now 9 halves is about, or is 4.5, 4.5. Should be able to plot that point at 0, 4.5. Okay, put a point there on your graph. Plot it, cover up y and solve for x. Or in other words, if y is 0, x has to be 9. Plot that point. Graph the line. Be as accurate as you can on the line so we can see where the solution is. And then go to the second equation. And again, plot points or use your cover-up method. When you use your cover-up method, you're covering up x. That means x goes to 0. Therefore, y is negative 1/6. Negative 1/6 is pretty close to 0. Then cover up y and solve for x. If y is 0, x is 1. Those points are pretty close together. You're going to have to plot another point. I'm going to suggest you plot a point out there at, say, 4 or 5. If x equals 5, then you get negative 5 plus 6y equals negative 1, and you have to solve. So 6y equals 4. Y, therefore, equals 4/6, or 2/3. Plot the point 5 2/3, and that's tough to plot, but you can get it. It's just below 1 there. And then be as accurate as you can when you draw your line. Right there. And I think if you do this right, you'll see that the intersection is, I need to be more careful when I plot that, don't I? From here, the intersection ends up being right there at, what is that, 2, 4, 6, 7, 1. 7, 1. Check it. Plug it into both equations. Does 7 plus 2 equal 9? Yes. Does negative 7 plus 6 equal negative 1? Yes. And there's our solution.